Let us see how to sort the data now. We have a data set called online retail sales data. We have imported all the data sets. Online retail is one of them. In that, there are various columns. One of them is unit price. What if I want to sort this data based on unit price? What is the syntax? So I give online retail dot sort underscore values, then give the column that you want to sort it on. Well, I want to sort it on unit price. So you just get that unit price and keep it here. And then either you can update this data set or you can create a new data set. I don't want to update this data set. I want to create a new data set after sorting. And then when you execute this, what is the output that you will get? Let's have a look at the head of that data set. Then what you will get in that head, let's say first 20 rows, if I try to print it, then you will see it has been sorted in the ascending order. The least value is here, followed by the next one, next one, next one. How do I know ascending? I can clearly see it. Or if you see the tail, which is like last 20 rows, you will see definitely ascending here from 5,000 to 6,000 to 13,000 to 38,000. That's the max value. So by default, it is sorting it ascending. If you want to do the opposite of it, if you want to do descending, because the default one is ascending, what you need to do is you have to use an option ascending. Right now, ascending is equal to false. Okay, ascending is equal to false. As you can see, as I type ascending, ascending is equal to true is the original default value, but I want to make it false because I don't want to do it in ascending order. If you say ascend equal to false, automatically it will be done in the descending order. Now, if I look at the head, now it will be descending order. Max value is 38,000. That's in the first row, followed by the next row, followed by the next row, followed by the next row. What if first I want to sort it by country? And when there is a match in the country, if the country is repeating, let's say if the first 10 rows are taking the same country value, then I sort it by unit price, or then I sort it by quantity. If I want to first sort it by a particular column, when there is a match, when there is a tie, then only I want to go to the other column. What is the syntax like? Let us see. So if you want to sort it by two columns, that means first by one column. And if you want to sort it by other column when there is a tie in the first column. Tie in the sense like the same column or the same value is repeated. So in that case, you give a list here. In that list, first I want to sort everything by country. And then when there is a tie in the country, when the same country is repeating twice, and then only then I want to sort it by unit price. You know what? The country I want to sort ascending. The first one, the country, I want to sort it by ascending order. That means in the alphabetical order, A for Australia, A for Amsterdam, like that. And then unit price, I want to sort it by descending. So I have to write ascending equal to true for country, ascending is equal to false for unit price. If that is the case, look at the output. First, everything will be sorted by country. So country is Australia, the initial country. When there is a match in the country, then it will be sorted by unit price. First few records are Australia, Australia, Australia only. Let us look at last few records. How does that look like? Unspecified, everything looks to be U, unspecified. So let us look at first 100 records if that is possible. Let us look at the first 100 records. Here is the output where you have, this is still tail. First 100 means head 100. Head of 100 records. Australia, Australia, Australia. These are all Australia. And when there is a match, it is just doing the descending order of unit price. Ascending order in country. When there is a match, then descending order in unit price. Sorting is pretty simple and straightforward. That brings us to the Next lab exercise. In this lab exercise, you're supposed to take auto data set, automobile data set, sort the data set based on the price, and then sort the database based on the price descending. That's what we want to know. So try to perform this sorting before you move on to the next subtopic. Let us see how to find whether there are any duplicates inside a column or whether there are any duplicate entries inside the data set. There's a data set called bill data. Here is the bill data. We have imported all the data sets in one go. If I want to know whether there are any duplicated values inside this data, in the sense if the same row is repeating once or twice, how do you know that? You write bill data dot duplicated. What is it? Duplicated. That's it. Then you will get to know whether there are any duplicates. No, first row is not duplicate, not duplicate. If the same row repeats twice, then it will be called as true. True means duplicated. So let's say this is known as dupe value, okay, or dupe indicator, because it's just indicating true or false, okay. Now, if you want to know total number of duplicates, that means you have to sum up all the true, true, true. True means one. So if you can just write either summation of trues or dot value underscore counts also works, okay. So sum of dupe indicator is 10. What does that mean? There are 10 true values in between. It means there are 10 duplicates in this data set. Remaining all are false, false, false. Remember, true means 1, false means 0. If you add up all dupe underscore indicator, all the trues will be adding up, all the ones are added up, and they are forming something called 10. If you want to drop those duplicates from this particular data set, let's say you have this bill data, and in that I want to drop duplicates. What I want to do is I'll just simply say bill data dot, I use a function called drop duplicates. Drop duplicates, that will drop all the duplicates from the bill data. However, that will not effectively drop it from bill data. I have to create a new column or new data frame out of it. Instead of replacing the original data frame, I generally tend to create a new data frame. So the new data frame is bill data unique, and then I'm forming that by dropping all the duplicates from the bill data. So if you see bill data dot shape, it will have how many rows? 9,462 rows. But bill data dot unique, that will have a shape of 9,462 minus 10. But how much that will be? 52 dot shape. Let us see. Here you go. Those 10 duplicate values got dropped if you want to remove duplicates. Now, these are the duplicates. The complete row is duplicated. That means the same row repeated twice. But sometimes if your primary key is repeated, let's say if invoice number is repeating, I want to consider as duplicate. Even row values are different. Or if the customer ID is repeating, I want to consider as duplicate. Look at this here. Here it is 262 14.95, but the customer ID is 12415. What if I want to say based on this key? What is the key? Customer ID. If based on the key itself, if that is repeated twice, I would like to consider all these three as duplicates. If that is the case, then duplicates based on the key, how do you find them? Here is the case how you can find them. So instead of looking at the duplicates on the full data, what you will do is duplicates based on the key, and mention the key here. What's my key? Customer ID. That's the key. Now duplicate indicator based on the key, or this is known as dupe key indicator. Key is customer ID. If the customer ID is repeated twice, I would like to call that as duplicates. Obviously, there will be more duplicates now, because if the key itself repeating, you are saying that is duplicate. There are 73 duplicates where customer ID got repeated. This is original duplicate, duplicate, because the same ID repeated twice. That happened with several other customer IDs as well. 73 times there were duplicates. Now, if you want to drop these duplicates based on that customer ID, here is how you do it. So bill data unique based on the customer ID. based on the cust ID. So build data dot drop duplicates. Inside this, you're supposed to mention the ID that you want to drop on. I want to drop on customer ID. Then what do? You execute this. So eventually, if you want to know what is the original shape of the data, in the build data, there are 9,462. In the build data unique, there are 9,452. But based on the customer ID, even more records will be dropped. So overall, the shape will be 9389. Those 73 records have been dropped because here I'm interested in knowing the duplicates even based on the customer ID. That's how you identify and drop the duplicates. That brings us to the next small exercise. Quickly complete this exercise, handling the duplicates, finding the duplicates, understand this problem statement. There is this complaints data from the telecom data analysis. Take this complaint data, identify overall duplicates, and remove the duplicates, identify duplicates based on customer ID, remove the duplicates based on customer ID. That's what we want to do. That brings us to the next point of discussion. But before getting into that, make sure that you complete this lab exercise. Now let us see how do you merge and join the data sets. If you have two data sets, if you want to join them, inner join, outer join, left outer join, right outer join, how do you perform that? We have discussed join in detail in SQL, and we just learned the syntax here, the exact concept behind the joins. You may have to be aware of that before coming here. So make sure that you watched that joins video in SQL. Then let us replicate the same in Python here. To be on the safe side, what I'll do is I'll drop all the duplicates from the data set. So there's one data set called orders data. So here is how it looks like. Orders data. In that orders data, you have something called unique ID. Now that's our key. And there is another data set called slots data, orders and slots. For a television commercial company, there are orders and there are slots. Even in slots, there is a column called unique ID. So what I want to do is I want to create a new data set called orders one. And what I want to do is from orders data, I want to drop duplicates. You can have duplicates as well, but if it is a primary key, if you want to join on that particular column, one of the table has to have unique values. That's why you can do many to many join as well. Just to keep things simple, what I'm doing is I'm dropping all the duplicates based on unique ID. That is orders one. Similarly, I want to create slots one where I want to drop all the duplicates based on unique ID again in slots. In slots data also, the column name is unique ID. So slots one, orders one are my two data sets that I'm going to use for merging. Let's say if you want to see what is the shape of orders data has a shape of 1366 rows and 9 columns, and slots has a shape of 1751 rows and 17 columns. Now, if you want to do the inner join based on the unique ID, orders data and slots data, the matching records, if you want to keep in one data set, let me call that as join data, inner join data, orders and slots data. So how do you do that? You use a function called pd.merge. pd.merge dataset 1 that you will write here, followed by dataset 2 that you will write here, followed by on, which variable on you want to do the merging, and then how, whether it is inner join or outer join or whatever it is. So I want to do inner join. My dataset 1 is orders 1, and my dataset 2 is slots 1. Okay. And I want to join them on what? I want to join them on a column called unique ID. So how it works is you write the data frame 1 orders, data frame 2 slots on unique ID, and that should be in quotes. And then how do you want to join it? It must be inner join. If It is inner join, whatever are the matching records that will be given to you, and all the columns will be given to you. There are only 8 matching records between orders and slots. If you want to do full outer join, a union of these two, everything that is there in orders, everything that is there in slots, completely if you want to take, then you can keep everything dataset 1, dataset 2 on unique ID. The joint up is full outer. For full outer, you simply put outer. Okay. By doing that, you will get 1366 plus 1751 minus 8, the 8 records which are common. The repeating ones will be removed. Overall, there will be 3109 records and 25 columns. The columns 9 plus 17 minus 1 is unique ID. So that column will be ignored. That will be 17 plus 8. That will be 25 columns. If you are interested only in orders data, if you want to do left outer join, you simply say in the place of outer, you simply put left. So orders data will be taken. That means 1366 records will be there, and the columns from, so it has to be not inner join data, it has to be outer join data. You have to rename that outer join data. And this one is left join data. Everything from orders data and matching records from the slot data. So 1366, that will be same as the orders. What if I want to do right outer join? You simply say right join data, right join data. Then here, how you want to join? I want to do right outer join. You just put right. So that's how joins work here. Very, very simple in Python joins. Just the way in SQL that we have seen, you can simply use right or left outer join. Let's say if you want to join on, let's say, 2 different columns. Let's say here just key is 1 only. If you want to join on 2 different columns, how do you do that? Let's say the same right outer join, but here on the left hand side, if it is, let's say, unique ID, on the right hand side, the ID name is different. If that is the case, then you say left underscore on whatever are the columns, or how many ever columns if you want to give, you can give them. Let's say left underscore on. The columns that I want to give are, let's say, add ID. So let's go to this orders data and have a look at the data. Add ID is one of the column and product ID. Those are the 2 columns that I want to use as key. A combination of 2 columns can be used as keys, not a problem. Add ID and product ID. Okay. Add ID, comma, product ID. Left side on or add ID, product ID. Then right on, I want to give, let's say on the right hand side, if there's a different set of columns, or if you want to be safe that these column names are exactly not repeating in the column this one, then you can also give something called right underscore on. Here you don't need to give that, but this is for your reference. Later on, you can simply give this if there is a different column. Let's say in the first data set, in the left hand side data set, it is add ID. On the right hand side data set, let's say if it is ID. In the left hand side data set, it is product ID. In the right hand side data set, it is just product. If that is the case, then you may have to give this way, left on, right on. And how do you want to do the join, left or right or inner or outer? That you can give it. By doing so, you will have the same number of records depending on this, because the key is different here. Add ID, product ID, definitely you will have much higher number of records. If you're doing it on unique ID, let's say on the left hand side is also it is unique ID. On the right hand side also it is unique ID. That will also work. Okay. And the join that I want to do is right outer join 1751, just like the other right outer join. So you can give 2 keys, which is a composite key. You can give 2 keys with different names on the left hand side, right hand side. You'll be able to handle different type of scenarios within joins. That brings us to the next part of the lab exercise. I want you to understand the problem statement here. So there is some data set called bill data, and there is a data set called complaints data. Somewhere we have used bill data, complaints data. So import the data set, remove the duplicates based on customer ID, keep the data set unique with respect to customer ID, and create a data set for each of these requirements. Identify what type of join that you have to apply, and then try to write the code to fulfill this particular requirement. Then we will move on to some of the advanced commands within pandas that will be very helpful. Until now, whatever we discussed, you must be very much aware of all this. And these are kind of the upcoming commands are a kind of optional. It's good to know. Even if you don't know them, you'll be able to handle data manipulations in general. But let us understand these advanced commands as well. Let us have a look at the credit card usage data. The dataset name is CC usage. In that, let us look at first a couple of rows to get an idea. This is credit card usage data, client number, attrition flag, customer age, gender, dependent column, dependent count, education level, matching status, income category, card category, months on book, hell, lot of columns are there. Pretty useful data, and it's a real data set, by the way. Okay. Now, imagine a situation where you have this column called credit limit. Where's that credit limit? Let's do one thing. Let us get an idea on that credit limit column. This is dot credit limit. How do you get a particular column and its description? You can use a function called describe. What it describes is how many records are there, what is the minimum value, what is the maximum value, etc. Okay. Credit limit dot describe. That will give you an idea. Credit limit. Is there a column called credit limit? Let us see. I think this is uppercase L. Yeah. And this is uppercase C. Case sensitivity. Yes. There are around 101 or 10,127 records. The average credit limit is 8,000. Standard deviation, you can ignore it for now. Minimum credit limit is 1,400. Maximum credit limit is 34,000. Okay. That is how the credit limit looks like, the description of it. What I want to do is I want to create a new column called credit limit segment. Credit limit segment. Right now, credit limit is actually a numeric value, but I want it to be discretized. Discretizing means I want to create it into three segments: low credit limit, medium credit limit, high credit limit. Low credit limit is from 0 to 3,000. I want to call it as low credit limit. From 3,000 to 6,000, I want to call it as a medium credit limit. 6,000 or above, I want to call it as high credit limit. I want to create a new column called credit limit segment. Okay. And this credit limit segment must take three values: low, medium, high. And how do I create that? You can use a for loop for this, and there are actually three different ways of doing it. Let us see what is the first method. Okay. So I want to create this new column, credit card usage, credit limit segment. Let's say that is 0 as of now. Now what I want to do is for I in range, starting from index 0, whatever is the length of, whatever is the length of credit card usage data, whatever is the length of credit card usage data. So what does it give? Length of credit card usage data. It will give you the number of rows, that's it, starting from the first row to the last row. CC usage, isn't it? Look at that. Length is 10,127. So from here to here, then if this particular value, what is it? Credit limit. If that credit limit of a particular row, that particular row is less than 3,000, if that is less than 3,000, then I would like to give this value credit limit segment. What's the value that it should take? It should take that value should be in that particular row. It should be, I'm talking about one row, like I goes by row. That should be taking as low. That must be low credit limit. I'll repeat the same stuff. And then if that value is, instead of using if, we have to use what? Elif. If that value is less than 6,000, that means more than 3,000, less than 6,000, then I want it to take median. If that value is the same value, or simply I can write else, whatever is the credit limit segment, I simply want to make it as what? High. That's it. I'm writing a for loop for doing all this. So I'm creating a new variable called credit limit segment. And this is the for loop that I have used for filling it. And Python is giving, Pandas is giving some warnings. Even with these warnings, everything will work perfectly. So what I'll do is I'll go here and try to check value underscore counts. What does value underscore counts give you? Value underscore count give you different values taken by this variable and what is the count of each of them. This particular variable takes three value, high, low, medium, and these many count. This is the count of rows. This is the count of rows, value underscore counts. If it is a continuous variable, you can use describe for describing a particular variable to have a quick summary. If it is a discrete or a categorical variable like this, which takes high, medium, low, you can use value underscore counts to check how many values that variable takes and how many times or the number of the frequency of times this particular value occurs. So we have used a for loop for creation of this new column. And let me tell you a tip. Using a for loop is never a good idea because for loop iterates over row by row, row by row, row by row. It iterates, and that's not a good idea. Instead of using for loop, in fact, you have to avoid these type of for loops as much as possible, especially on large data sets. They will take hell lot of time. You have to use other alternative ways of creating this. Here it worked quickly, but in reality, if you have a large data set, it will take hell lot of time. So you have two other options. There are two other ways of doing it. One way is vectorization. You can achieve the same job by doing vectorization. How do you do that? You use credit card usage, credit segment. Let me create a new column. Okay, credit segment one so that we can compare. This is the one that we created using for loop. This is the one that we are using vectorization. Let me fill that as high first. Everything has been filled as high now. A new column is created. I'm just filling it as high. Now I'll go to that column, apply a filter condition here. What is the filter condition? If the credit limit, if the credit limit, that's the filter condition. If the credit limit is less than 3,000, look at this filter condition carefully. We will go to this particular data set. We will go to this particular place which is credit limit segment. Right now it takes high, high, high everywhere. Now what we will do is we will go to those points of the data where the credit limit is less than 3,000. If you see the condition here, it simply gives you true, false, true, false, true, false. A Boolean way of subsetting is also there, right? So we are accessing only those places where the credit limit is less than 3,000. And I want to fill them as low. Okay. So now there will be high and low. There is one more condition. What is the other condition? If the credit limit is greater than 3,000 or greater than or equal to 3,000, and there's one more condition. There are two conditions that I want to apply here. If the credit limit is greater than 3,000 and the credit limit is less than 6,000. If it is less than 6,000. Condition 1, credit limit is greater than 3,000 and condition 2, credit limit is less than 6,000. Then I want to fill that as medium. Credit limit high, low, medium. These are the three credit limit values that I am taking. Now, if you see credit limit segment 1, this particular new column, previously we have created that using for loop. Now we have done vectorization using vector. Again, you will get this warning. You can ignore that warning. That's perfectly fine. With this vectorization also, you'll get the similar results. But vectorization is supposed to be damn quick. For loop is 100 times or 200 times time consuming, especially for large data sets. Let me give you a demonstration of what is the damage that your for loop can do, especially if your data set size is very large. To demonstrate the time consumed by for loop versus vectorization method, let us take a slightly larger data set. If you take online retail sales data, I guess that was slightly larger in size. Dot shape that you see, there are nearly how many rows are there? There are 2,97,000 or 297,000 rows are there. Still not very huge, but decently huge. Let us create, let's say, high, low, medium on something called unit price. So online retail sales data has a column called unit price. I want to create high, low, medium segment, something like this using for loop, using unit price. Okay. So how do I do that? Let's say if the unit price is less than 2, I would say low, 2 to 4 medium, more than 4, it is high. That's what I want to write the code as. So let us write the code. First, we will do it by for loop. Let me also measure the time. So import time. Time is a package. Import time package. Let's create a variable called start time. So right now the start time is equal to time dot time. Time dot time. So it will just start with the start time. There is this funny thing with Colab. It keeps on giving these combos and all that. Ignore them. Start time is equal to time dot time. And then I would like to go to online retail data, and then I would like to create something called unit price segment. Unit price segment. Okay. Online retail sales data, unit price segment. Is this our data set name exactly? Or is it uppercase? Now that is uppercase. So I'll make sure that I give that unit price segment. As of now, I'm filling it as high. Unit price is high. Now let me run the for loop. For I in range. What range? From 0 to the length of online retail price data. Instead of length, you can use another option called shape of online retail price data dot shape. In that shape, you have two elements. What is the first element? The number of rows. Either you can give it this way, or you can give it, you can use length also. Okay. For I in the range, this one, what's your condition? If unit price, so in this online retail, unit price, where's our variable unit price? Let's get that unit price. If unit price is less than 2, by the way, that's ith row, whichever is the row. If that is less than 2, then I would like to say, what I would like to say, unit price segment is low. Okay. If it is less than 2, then the output is unit price is in this float values. You can give 2.0 as well. Okay. Just to be on the safe side. Then I would like to say online retail price. If this condition is satisfied, then that particular row, that particular segment variable, I want to fill it as low. And I would like to repeat this whole thing again. Okay. And then I would like to say else if, which is like elif, if that is less than 4, earlier less than 2, less than 4, now that means it is 2 to 4, that is medium. Anyway, the remaining one we have kept it as high. You can write else high also. Otherwise, anyway, we have filled everything else as high only. So this should be fine. This 4 must be working. Now, what is the complete time taken? So time taken, or it is known as elapsed time. Time taken is equal to what is the current time? Time dot time. And before executing, what was the time that we stored? Here we stored in start time. So current time minus whatever was stored in start time. So you can, I'm not interested in the final result. I'm just interested in time taken. So let me print time taken, how much time this for loop takes. And for loop takes actually a lot of time in this particular code. It is executing. While it is executing, let's not waste any time. We will do the same job. Look at this. It is running in the for loop here, here, here. It's keeping on going, executing 11 seconds, 12 seconds, and so on. While it is executing, what we will do is we will try to achieve the same thing using vectorization. Okay. So let me copy paste the same code, but let us modify it for the vectorization. So the time taken and all that start time and etc. Everything remains same. Online retail sales unit price segment one is what I want to create. But this code instead of for loop, I would like to do vectorization. So the first statement is the first filter is from the online retail sales data if the unit price is less than 2.0. So let's take that first command. So here we will put the first filter condition. It's not I. If unit price is less than 2, then I would say it must be low. And second time I'll be writing two conditions. What is it? If it is greater than 2, it is greater than 2. I have to put parentheses also. And less than 4. Greater than 2 and less than 4. Medium. You don't really need to write all this code just for the comparison. We are doing it. Okay. You just focus on what is vectorization, how it works. And then, as usual, we will try to measure this time as well. Look at the above code. This for loop is still executing. It's been 1 minute, 55 seconds. It is still going on. It's been like what? 120 seconds or over. But still it's going on. And you will be surprised to see the speed at which our vectorization works. First, let us see the time taken there. Let me store this in time taken 1 so that we can compare both the time taken. It is still executing. Let's give it a, let's wait until it executes. It may take 1 more minute, I guess. How much time does it take? The above one, let us see. It's been almost 2 minutes. Look at this. We have just nearly 300,000, one third of a million, or 297,000 records are there, but still it is taking a lot of time. We haven't yet executed vectorization. Let's complete for loop first, then we will go to vectorization. As I told you, for loop is a very much time consuming affair. You must avoid for loop as much as possible, especially when you're working with large data sets. It is going to take hell lot of time. Try not to use for loop as much as possible, because fundamentally for loop is going row by row, row by row, row by row. Whereas vectorization, it is taking everything in one shot. The whole data set unit price has been checked in one shot. Within one shot, you're doing everything. So it will be consuming much, much lesser time for sure. Very much lesser time. For loop is still executing. Let us see how much time does it take this for loop. Nearly 4 minutes we are approaching. Nearly 240 seconds for a data set like this. Imagine a data set where you have millions and millions of records. Once you write a for loop, it will execute forever, especially if you have very large data set. That is not a good sign. Let's hit execute. Let's click on executing. It's executing. Go on. Finally, for loop given us the result, and the time taken is 307 seconds, nearly 5 minutes. You may think 5 minutes is not a big deal, but think about this. It is just data handling, data manipulation exercise, and we don't want to spend that much time on it, especially when you have an alternative like this, where you do vectorization. That's it within a flash. Vectorization took 0.02 seconds and 300 seconds. 307 seconds for loop. So if you divide this, the number of times faster vectorization, how fast vectorization is this divided by how much? 0.02. It is less than one-fifth of a second, nearly. How much is this? 13,000 times faster. Vectorization is 13,000 times faster on this data set. Factorization is crazily fast. Try to avoid for loop as much as possible. So when you're working with data sets and if you have to do iterative process, instead of using for loop, try to use this option of factorization. That is one way. And there is one more option called we can also use apply function. That is also relatively faster. But vectorization is something that I suggest, especially when you want to create columns like this. Okay. Let us see what is that apply function. Before getting into apply function, let us do a quick lab. Once again, we want to make sure that we understand the difference between for loop and the vectorization. The one that I have executed here, online retail sales data, you also do it from your end. Earlier, I told you that just for the sake of understanding, we are executing it. If you haven't executed it, make sure that you write the code for this and also look at the time, how much vectorize. It may change from system to system, but one thing is for sure, for loop, no matter what system you're doing, it will take much more time than vectorization for sure. Now let us see what is this apply function and how does that work. In the previous example, we worked on two different data sets and different variables. For example, we started with credit limit, and credit limit segment is what we have created. And then we went to online retail sales data. There we have created unit price segment. This is unit price segment, and the previous one was credit limit, high, low, medium. Okay. So basically what we did here, we converted this continuous variable, which is credit limit, and we binned it. We made it into three buckets or three bins, high, low, medium. Originally, it has a huge range, but we converted into high, low, medium. Even unit price also has a huge range. It is going from anywhere between 0 to almost 13,000 or something like that. That also we converted into three bins. What is it? High, low, medium, isn't it? This is called binning. We have converted into binning or bins, or we have discretized it. So what we can do is using one apply function, what we can do is we can define that binning function outside and we can apply it on each and every row. So how is that possible? Let us see. How do you achieve the same thing using apply function? In Python, you can do the same job in two or three different ways. Not every time you have to do it in the same way, or everybody must not do it in the same way. However, there are some effective, efficient ways. It's better to learn them so that you can use them while you are working on them. So let me define a function. First of all, I'm defining a function called, my function name is binning. It takes the original variable and whatever is the limit one, whatever is limit two. Especially I'm defining it for cases where I want to simply create high, medium, low kind of bins. Okay. Given a numerical variable, if you give me limit one, if you give me limit two, for example, if you give me limit one in unit price data, the limit one is two, limit two is four. That means less than two, low, less than two to four, medium. Anything else is high. Or in credit limit data, your limits are less than 3,000, low, 3,000 to 6,000, medium, above 6,000, high. That's what I want to take as input. Once you give them as input, then what is the result that I want to give? So let us start with the result. The result initially, I'm initializing as result is high. Okay. If the value of x is less than limit 1, that means, let's say, for example, limit 1 is 3, less than limit 1, then what is the output? The result should not be high. The result must be changed to, results must be changed to from high. If it is less than limit 1, it must be low. Okay. What is the other condition? If it is greater than limit 1, but you have to have first condition, if it is greater than limit 1, and then there is an and it is less than limit 2, less than limit 2. So basically what I'm trying to say is, if unit price is less than 3, then low unit price. If it is 3 to 6, then it is medium unit price. Everything else will be called as high unit price. Okay. So what do you want to return out of this function? By the way, you have to put semicolon here, colon here, and then hit enter. Then you come out of this. What do you want to return? What is the return that you want to produce out of this function? I want to return result. So what will be the result that will be given? Either high or low or medium. If the value is less than limit 1, it will be returning low. If the value is between limit 1 to limit 2, it will be returning medium. Otherwise, it will be returning high. That's the function that you first need to define. The function name is binning. Here you will not get any error because you can write literally anything in the function. Then what is the code? Let's say if you want to achieve this, whatever you have done here in the credit limit segment 1. So if you want to create something like this, credit limit segment 1. So let me create credit limit segment 2. Credit limit segment 2 is equal to, I will go to credit card usage data, and then I will take credit limit. I will take credit limit. You take the data set name, you take the column name. Okay. This is the column name, and you write dot apply. You write dot apply, and then there is a function called lambda lambda x. Until here it is syntax. You always take data frame name, column name, dot apply, apply, lambda lambda x. Until here it is syntax. Here the x represents each value in this credit limit. And what I want to do, whichever function you want to apply here, let's say if you want to find the absolute value of credit limit, then you write absolute value of x. If you want to multiply credit limit with 30, then you write x into 30. But here, which function I want to apply? The function that I have defined here. I want to take x, I want to apply binning function. So x will be the input, and less than 3000 is low, 3000 to 6000 is medium. So this is the function that I'm planning to apply. So x, what is x? X here represents one particular row in credit limit, and this will go for each and every row. So that's how credit limit segment 2 is created, and this is also not very much time consuming. This is also very quick. You can repeat the same on online retail sales data. So here unit price segment is what we are creating. Let me call that as unit price segment 2. Once again, what is the syntax? I will go to online retail sales data, and then I will take the column. What's the column name? Unit price. I will take that unit price column. And then what is the syntax? Dot apply. Dot apply. Then lambda lambda, then x. Now that is syntax. You have to write it always like that. Dot apply lambda lambda x. Okay. And then whichever function that you want to write. This is the binning function that I want to use. And I want to supply x. This is the binning function. I want to supply x. And if it is, what is the limit one? If the unit price is less than 2, second limit is 2 to 4. So the limits will be, limit 1 will be 2 here and then 4 here. If you execute this, I think the same time that vectorization took, nearly about the same time this will also take. Only for loop takes a lot of time. Even this one also not taking much of time, under a second or max to max 1 second it is working. So here lambda is a temporary anonymous function. This is known as like lambda function. It's a temporary anonymous function. What is it doing? It is created to apply this particular function. Binning is another function that we have created. To apply binning function in this apply function, we are creating is for temporary purpose. Okay. But you can, if you want to understand it easily, you can consider this as syntax. You write it down, data frame name, column name, dot apply lambda x. So x represents one particular value of unit price. And what do you want to do with x? I want to do binning or whatever function that you want to apply. If you want to multiply x with 30, that is also possible. If you want to find the absolute value of x, that is also possible. If you want to divide x by 2, that is also possible. So lambda function takes each row and supplies it to the binning function or whatever function that you were giving here, then returns the result, and we are storing that result in unit price segment 2 finally. The result, so basically this lambda function is taking x, supplying it to binning, getting the result and storing it in unit price segment 2. That's what it is giving as result. Not every time you may have to define the function here. You can write sometimes simply x into 2 or x into 5 or something like that. So let us suppose if you want to create, if you want to experiment on customer age segment, for example, here I want to create a customer age segment. Okay, age segment. There's a variable called age. On that, I want to do segmentation. So in CC usage data, there is a variable called age. Apply lambda instead of binning if I want to write everything here itself. If age is less than 50, I will say segment 1. If age is more than 50, I will say segment 2. So lambda x, the output is segment 1. We can write list comprehension format. Segment 1, if x is less than 50. Else, the output is segment 2. You can write it this way also. But if you write it as a function outside, then it will be clear to you. Here also you can write it, but it will be little confusing. So the output is segment 1 if x is less than 50. Else, the output is segment 2. So age will be taken as input and x will be supplied and segment 1 or segment 2 will be given as output. Then you will get to know how many customers have age less than 50, how many customers have age more than 50. So you can do value underscore counts to get an idea on how many customers are in segment 1, how many customers are in segment 2. So the age itself, do we have a variable called age or is it something else in unit in this credit limit data set? Let's get an idea on that credit limit data set. Usually this key error comes when there is no column name called age. Let us get the actual column name, customer usage dot head, or let me just get the columns. Customer age, it's not just age, it is customer age. So then you get the right answer. This is also for segment 1. Customers with age less than 50 are 6597, age more than 50 are 3530. So you have to give X and you can write any logic here. That's what this lambda function is going to do. So right now, if you see this, lambda function is working row by row. It will apply this binning on the first row, then go to the second row, then go to the third row, then go to the fourth row, then go to the fifth row. It is going row by row. You can use this apply function to apply on columns as well. So here, what are you doing? You're going to unit price every row by row and checking whether the unit price is less than 2 or more than 2, then creating a new column called unit price segment. Here you are going row by row, row by row, row by row while checking. What if I want to do an operation where I want to go column by column, column by column? Let's say I have a data set, I want to find the mean of the first column, then go to the mean of the second column, then go to the mean of the third column, then go to the mean of the fourth column. I want to calculate column by column, column by column, column by column. Can I still use apply function? Yes, you can use apply function on columns as well, but with a little modification, you have to do it. Let us see how to use this apply function on columns. Let us see how this apply function works on each column by column. Here the apply function is running on rows. If you want to run them on columns, first of all, let us take this CC usage data. From that, I want to take all numerical columns. So I'll use this option called select data types, select D types, select D types and exclude all the object column. So exclude is equal to object. Exclude is equal to object. Now let me store that in a new data frame. Let's say CC uses numeric calls, numerical columns only. Okay. CC uses numeric calls and I'm excluding everything that is of the type object. So original dataset has several columns, but this time I'm focusing only on numeric columns. Okay. Apparently, client number is also numeric. We'll ignore that. Client age, dependent count, months on book, total relationship count, months inactive, credit limit, average open to buy, total amount, etc., etc. There are so many numeric columns, of course. Now, for every column, if I want to calculate average, I want to calculate average credit limit, I want to calculate average age, I want to calculate average of number of dependents. For this column, average. For this column, average. For every column, I want to calculate average. I want to go column by column way. Earlier, I was running through rows. Now I want to run through columns using apply function. What that would look like. So let's take this data frame name and then use dot apply, and what is it? LAM PDA X, or here let's call it as Y just to have a distinction. You can write X also. Let's call it as Y. Okay. So dot apply lambda Y. So Y here represents one column. Okay. So I would just simply want to find, I want to return Y dot mean. I just want to give the mean back as the output. However, if you do this, it is not going to work. It's going to work, but what's the problem here? Dot apply y dot mean. So it's giving us this output. When you say y dot mean, it is giving us this output. What we will do is to make it a little understandable, we will use round function so that we can read the output carefully. So the client number, average, we don't care. Customer age, average, customer dependent count, etc., etc. This is working on columns as well. Column by column, it's going. But how do you dictate it? Earlier, it was working on rows. Now it is working on columns. How do you take the matter into your hands? How do you tell the apply function that I want you to go by row and then do the calculations like the way that I have done here? In every row, I want you to apply it on the customer age. Or how do you explain it to tell the particular lambda function that it must be applied on column by column? Since you have given the complete data frame here, it has understood that you have to apply it by column. But how do you take that matter into your hands? How do you tell that to apply function or lambda function that you have to do sometimes row by row, some calculations. Sometimes you have to do, like in this case, you have to do column by column. In that case, you have to use an extra option called access. Let's say if you want to run column by column, let's say within a column, you want to aggregate all the rows. Within a column, you want to aggregate all the rows. Okay. Then if you want to go column by column, everything, then you must use the option access equal to 0. This sounds slightly opposite to what we have done in drop function, but here column by column, if you want to do the calculations, you use access equal to 0, then it will go by column. What if I want to do calculations row by row? First row, I want to do the calculation. Second row, I want to do the calculations. Then you put access equal to 1. So for an example, earlier, what we have done here is in this customer age, we have created age segment, or let's go to this unit price segment. Here in each row, I want to check the unit price. I want to divide that into high, medium, low, high, medium, low, high, medium, low in each row. In that case, you have to give access equal to 1 because you want to do row by row calculations. If you want to do column by column, here we want to calculate the average of first column, average of second column. If you want to do column by column, then you use access equal to 0. So if you want to specifically mention what kind of calculation you want, row-wise calculations or column-wise calculations, you can use apply lambda function, but you have to use an extra parameter called either access equal to 0 or access equal to 1. You can also apply the condition on multiple columns to create the new column. You can use apply function. For example, in this credit card data set, let's go to this credit card data, CC usage data. In this data set, if it says the total relationship count, if the total relationship count is more than 4, if there are more than 4 relations, and if the credit limit is less than 5,000, if somebody has more than 4 relations with us, and then if the credit limit is less than 5,000, maybe they are good customers, we must increase their credit limit because they are loyal customers, their number of relationships count, they have several accounts with us, let us increase that. So how do you flag, like say here within a row, you want to check whether the number of relationships is greater than 4, and if the credit limit is less than 5,000, I want to return them as 1. Otherwise, that is credit line increase, I want to make the credit line increase. So let me create a new column for that operation. So let us get all those columns. So let me define a new function, def credit line increase flag is the new column that I want to create. Credit line increase flag. Okay. And that takes X as input. Okay. And what I want to do is X has actually two values in it. It has two components. Okay. What is it? If X of 0, that means the total relationship count that is greater than 4, and if X of 1, which is the second component of X is a list actually that I'm taking as input, if that is less than, second element of the list is less than 5,000, then what I want to do is I want to return 1. You can achieve this in different ways also, but if you want to use apply function, how is it done? Else I want to return else I want to return a 0 here. Okay, that is it. This is a simple function which will help us in increasing the credit line, because a customer has more than 4 relationship counts, we want to increase the credit limit. So how do I use an apply function? Here the apply function, does it need to be applied row wise or column wise? Look at it. If you look at this data, apply function, this apply function, CLI flag, row by row, row by row, row by row, will I be doing that, or will I be doing column 1, column 2, column 3, column 4, or all the columns? Am I applying this on all the rows, or am I applying this on all the columns? Think about it before you write the function. So let us write the function. So CC usage data, in that CC usage data, what I want to do is I want to create a new column called credit line increase flag. Credit line increase flag is the new column name that I'm creating. So what I'll do is I'll go to CC usage data. In that, I'm going to take two columns, by the way. Okay. Out of this, how do you access only two columns? So a list of two columns. The first column is total relationships count. Okay. So it's here, total relationships count. The average itself is 4 for total relationships count. That's the first column. When you're taking two columns, you're supposed to use an extra parenthesis because you are giving a list of columns as input. What's the second column? It's the credit limit. That must also be here. Where is that credit limit? Here you go. That is a credit limit column and the credit limit. So these are the two columns that I'm giving to the apply function. So you write dot apply as usual, and then you write LAM BDA lambda X, and then, and what is the function name? The function name is CLI flag. It is taking these two. Okay, CLI flag. And what does it take as input? X. This X represents these two columns here, list of these two columns. Since we want to apply this on row by row, row by row, from here on, to be on the safe side, if you are applying row by row, you give access equal to 1. If you're applying column by column, give access equal to 0, so that we are very sure that what is happening. Okay. So if you give this, what it'll do is it will create this flag. You will get to see value underscore counts is giving you zeros and ones. For these people, 2000 people, it's time to increase their credit limit because their relationship count is high, but their credit limit is less. If you don't give access equal to 1, what is happening? Is it going to still work the same way? Let us see. It's not working because you're taking these two columns, it's going by column. It's not working properly. So this is the case where you're supposed to give access equal to 1 carefully so that we are dictating in which manner this must go. In row by row manner, this must go. This apply function along with lambda is an interesting combination. You must understand this carefully. If you haven't understood this, try to do it a couple of times so that you will get clarity on this. What I want you to also do is try to practice this twice or thrice or and definitely we have a lab exercise on this. Try to understand this data set, bank telemarketing data. Take this data set, understand all these problem statements carefully one by one. Make sure that you execute this, you complete the supply function before getting on to the next topic.